Hello everyone. In this video tutorial, we are going to see how to load the data to our project so we can run our Markdown and do analysis of the data set. We are also going to check ways of seeing the structure of the data set and how to make graphs for qualitative data sets. In this lab, we do part 1 of graphing, but before I go over some of the functions and tools described in this lab, let me show you the error message that appears when an R package is missing and it is needed for the R Markdown document. At this point of my document here, an error message appears on the top of the screen. There is a red banner and in it says error compiling R Markdown. So if we check the build log, you can see that there is an arrow indicating where in my document, which line is 120 and 122. The arrow appears in the part of the code that says library summary tools, and it tells me that there is no such package called summary tools. That means I must install this package in my project. I already installed the R packages needed for my lab. I'm gonna move on and see ways of getting data into R. Since we wanna do some data analysis, we do need data sets. One way of doing that is by actually asking R to simulate a particular distribution with the properties needed. So in this particular piece of code we have here, we have the rnorm function in R, which is going to generate a distribution of a certain number of values with a mean specified, in this case 50, and a standard deviation, in this case 25, and that distribution is what we call a normal distribution. We are going to cover normal distributions as a topic later in our classes. So this piece of code is asking R to simulate a 100 value that has this normal distribution with mean of 50 and a standard deviation of 25. And after having this distribution, we're going to ask also R to plot the histogram of the distribution. So let's build. So R is running right now. The Markdown is being rendered. Okay. So here you can see, right, getting some data from R and the plot of the data set with 100 values, which correspond to a normal distribution, is given here. Another way of getting to do some data analysis is if we really get a data set with real information, right? So in real life, we have a lot of information that we would like to do some analysis. And in this case, in the particular example we're going to see next, it corresponds to a data set that contains information about film permits issued in New York City. This data set from a website that's called NYC Open Data, and in that website they collect all different types of data sets related to New York City. These data sets are downloaded from the internet and they put in your project. So conveniently, you already have the CSV file in your project. We can use what's already in your project, or if desired, if your project has access to the internet, you can ask R to pull up the data directly from the website. All you need to do is actually to provide the link to access that data set online. In order to load the information in that file, we're going to use the library called data table. Now, data table is a R package that provides like an enhanced version of a data frame, and data frame is just the lingo used in R for what we call tables. So here in this piece of code, we have that we first going to load the package needed, which is called data table. Under that package, we have a function called fread, basically file read, in parentheses the name of the file with the extension and between quotation marks. So what it's gonna do is gonna read all that information in the file. So when it reads the information in the file, this notation here, this syntax, ask to put all that information in a single variable called NYC underscore film. And we're going to use that variable for manipulating the information, reading the information, plotting the information, and so on. Now, what if I want to take a look at the structure of the data sets? I would like to have a little bit more of information on what is contained in the file. In this bit of code here, we can see from R, we are using a function called dim for dimensions, and then dimensions of what is contained, the data frame contained in the variable NYC underscore films. Whatever that dimensions, meaning how many rows and how many columns I have in that data frame, is gonna be put in a variable called data size or data underscore size, okay? So once it puts in that variable the information I'm requiring here, which is the size of this data frame, I'm gonna ask R to display for me what is in it. So by just typing what is the variable containing that information, it's gonna output what is in that variable. So let me quickly build here to be sure that I have a fresh information, and then once my file is rendered, I'm gonna scroll down and see what I obtained from all these functions so far. So what we see here is that from the library data table, which is uploading the R package to read the information in the file, which is now in NYC Films variable. We actually ask what is the size of that data file, right? How many rows and how many columns. Now, the output from that is that there are 70,989 rows and 14 variables. So it's quite a lot of information there. We have 14 variables. Another way is also knowing what the variables are. What is the information for each variable that is contained in the file? So what we can do here with the next piece of code in R is that we have what's called call names. So basically the names of the columns. Remember, this is a data frame, a table, and it has columns and rows. So each column will have a variable associated to that. And what we're asking here with this function in R is to display the names of the columns in the NYC Films data frame, the table. Another piece of code here, as you see, there is head NYC Films. So we're asking the top rows of the file, what is contained in that file. So it's going to display the first few rows of the file. Alternatively, you could ask to see the tail of the file, meaning the last few rows of the file, right? So it's tail, parentheses, inside parentheses you put the variable or your data frame variable, which is NYC Films. Here is structure, column names, head, and also there is a view function. So I recommend you to try all of them to see what the outputs you get. Okay, so let's look up for the information here. So because I just rendered the R markdown, so this information is still accurate, okay? So you can see here that by calling the function call names, the name of the columns, you have 14 variables associated to that. For example, event ID is number 1, event type 2, start date time is the third column, and then you can see here it starts with number 4, meaning the fourth column, and the date time, and then the fifth column, and so on. So if you count how many of them, so you can see the 13th column, which is country, and then there is 14th column, which is the zip code area. So it's give you a pretty good idea what is contained as information in the data file. Also remember that I'm asking R to display the top rows of the file, not just the name of the columns, but actually some of the information in those columns. So we have, for example, for event ID, the first row has this as an ID, the second row has this as an ID, and so on. And you can see that it's displaying from rows 1 to 6. So the first column, 1 to 6 values. The second column, which is event type, notice that this is the second column. you have shooting permit, shooting permit, shooting permit. So a lot of this is shooting permit. You can see here that in the fifth row here, theater load in and load out. So these are permit, some types of permit also issued, and so on. It gives you a good idea what is contained in the file, right? So if you scroll down, you can see more information. So parking held, and then it tells you the streets and so on, where it's holding those permit and so on. We can use graphs to answer certain questions we might have about a data set. In this lab, we are going to use the R package dplyr, which provides a set of tools for efficiently manipulate a data set in R, and also ggplot2, that is a data visualization package for R. GG stands for Grammar of Graphics. So now let's take a look at the following chunks of code. So in this chunk of code here, we have that the library dplyr is being called. Basically, we are loading the dplyr package. By the way, there's no need to install the dplyr package because CodeCalc already have it installed. And now, from our variable above NYC films, which contains the data frame with information about the film permits, we are going to group all that data according to the variable borough. So for each borough of New York, we're going to group the permits we have for that. And basically in this code, we also count how many entries we have for each of the boroughs. Then we're going to have a summary of that. Once we have all this done, R is going to store the information in a variable called counts. In the next chunk of code, we are loading the ggplot2 package, also already installed in CodeCalc. And then with ggplot, we're going to use the variable above, the summary above according to boroughs, counts. AES stands for constructing aesthetic mappings. Basically, it's a way of describing how the variables in our data set are mapped to visually properties of geoms. Geoms are basically layouts of the ggplot layers that we're going to construct one on the top of the other. Here you can see that the package dplyr is being loaded. It echoes some information which is not important for us at this moment. And then we have also the piece of code for the variable counts. And then we ask ggplot2 to display that with a bar graph, right? So we have geom underscore bar. So basically we're putting a layer into our graph that correspond to the bars. And notice that basically by looking at this graph, we have immediately information that Manhattan is the borough where most of our permits are requested for. If we want to find out what kind of categories of film are being made in New York City, we can modify the code above to identify the categories of the data set. So in the data set, there is a column called category. So the code above is modified. So we now have the same data frame, NYC films, but this time we are grouping by categories. And when we summarize count of permits, notice that also I needed to change inside the function length, where instead of borough, now we have category. If we ask ggplot to plot that for us, notice that I also need to change the x-axis to reflect categories. Let's build the graph. Okay, so it's rendering. We have this as a graph. The graph came out a little bit weird in a sense that you can see that the labels of the horizontal X, which are the categories of movies, they are overlapping. So we can adjust that. So next part of the code, you can see here that we add a line to the code. Notice there is a plus after the previous code, which we copy and paste, and then plus, add the last line, which basically change the theme, the horizontal axis text change by a rotation of 90 degrees. So we're rotating the text. So the result is this graph. So you notice now that the labels in the horizontal axis are good. We still need to put a little bit more information. Maybe a title would be great. So we have that we can change the label for the y-axis. So it's the same code as above, but notice that in the end, plus the Y label instead of count of permits, which was the name we gave for the frequency of the categories, right? That's automatically go into it. We better rename that as the number of film permits. We also would like to rename the horizontal axis, x-axis, with the function xlab. So we're gonna add that layer, so plus. We're also gonna add that layer. So now the horizontal axis instead of category, which is the name for the variable that come from the original data frame. We're gonna rename that to be more informative. It's category of film. We also would like to give a title. So GG title, parentheses, is how we give a title to the graph. And on top of whatever was before, we adding another layer to the ggplot. So plus, and then GG title, and then the new title will be number of film permits in New York City by category. Running all those codes give us so far this as a result. So it is a good graph, right? It has the title, it has a more informative horizontal and vertical axis. The labels of the horizontal axis do not overlap, so we definitely can read them. But maybe we want to also add color, right? Color to the graph, so we can do that. So notice that the X is equals to category because we're using that variable to create the whole graph, right? So we're counting the permits according to category. So in the main part of the ggplot, the beginning of the ggplot command, which is still the same as before, except that we adding color equals category. So basically, I'm telling R that the color has to be added, and it's going to be added according to categories. No other variable will be used to make the distinction in color except the category. Okay, so if we run that code, you can see here that the color was added, but maybe filling the color would be more appropriate. And also, by adding color, the ggplot also generates a legend. So this is redundant information because we already have the horizontal X label like that. So we want to get rid of that. We want to fill in the color in the columns. So the way we do that, so the filling part, right? So remember, we just add this bit right here, which tells R to add color to the graph. But the fill of the bars in the graph also need to be done. And that, again, you need to tell R that is based on categories. So the other bit that we add in here is we want to make the legend either on the bottom or removed. In this case, the code is showing on the bottom, and the following code is saying remove the legend by making the position equals to none. Once we run this code, so you can see here the part that fills in. So now all the columns are colorful completely. We want to remove this or move to the bottom first and then remove just to see the difference. So if you want to move, there is the bottom position for the legend, or you can remove completely. I like the way it looks right now, but maybe some people would like to have a background that is white. So we do have a theme classic that does that. The theme classic, which was added as another layer to the ggplot, so plus, and then theme classic. If you run the code up to this point with the theme class, you can see here that the background became white, but again, the graph is acting up a little bit, right? Again, I have the problems with the labels, the legend came back. The problem is that the order of the layers of the ggplot matter, okay? And in this case, instead of adding the theme classic all the way on the bottom, you want to add the white background in the beginning of the construction. Remember, the ggplot is adding layers where each layer will modify the way the graph looks, right? So you want that background be one of the first few things in the graph and everything else being put on top of it. So if we move that line of code from the bottom to up right after the geom bar, so the background has to be right there, right after the geom bar. So if you move that there, you're going to see an adjusted graph now with all the components, all the layers added to that, adjustments added to it. ggplot allows you to do a lot of modifications. It depends what you want to accomplish with these modifications. Also, be mindful that sometimes if you just adding layers, just keep improving, sometimes they may acting up the order of the layers effect. So maybe you want to move them around to see what's the best effect for your graph. If you continue with the rest of the lab, you're going to see also that there is a possibility of changing the size of the fonts and so on. Now we are going to see a few more things about the ggplot2 and dplyr package. Let's assume that we want to group the data frame we have with NYC films, but grouped by borrow and categories, all right? So notice that in this chunk of code here, the difference from above is that we are grouping according to borrow and category, and what we actually count in the grouping is categories. We are going to count how many of each category in each of the borrows. So the ggplot code from above remains the same mostly, except the last line where we added another layer to the ggplot. We are using the facet wrap function, which basically creates a multi-panel of graphs. We are going to have 5 plots, one for each borrow, and each plot contains the number for each of the categories. So the facet wrap is according to borrows, so we're going to have panels of 3 graphs at a time. So the result of this code is displayed here. So you can see that there are 5 graphs, one for each borrow, and each graph displays the number of film permits according to categories. Now, we also can use the package dplyr for filtering data from a data frame. So we still have similar code as before, but note that NYC film data frame, which is being grouped only by categories, and we are only filtering for when the borrow has the value Manhattan. And we count how many for each categories in the borrow of Manhattan. So the code for the ggplot remains pretty much the same with few modifications. We also modified a little bit the title to say now that the number of film permits in Manhattan by category. So note that when the plot is output, we have the same graph we had above in the facet wrapping code. Now that you saw a little bit of how to use the packages ggplot2 and dplyr, you're going to take the chunks of codes in this lab, modify to apply to the exercise in this lab. I wish you good luck. Have fun.